Okay, remember a coterminal angle is two angles that have the same initial side, which will always be the positive x coordinates, or x-axis, the positive x-axis portion of a quadrant. And then it's going to have the same terminal side as well. Okay, so if we took this angle right here and said this was 100 degrees, and we wanted to find two coterminal angles, one positive and one negative. Okay, what would be a positive coterminal angle with this? Remember, it's going to rotate all the way through and then continue all the way to the same end. So this rotation is 360 plus another 100, so you get a total of 460. And then in the negative direction, we start here and rotate in this direction. Here we take 360 and we subtract the 100. Now 360 minus 100 is negative 260. Okay, so remember positive coterminal angles. Or to find coterminal angles, you're going to take the original angle and you're going to add or subtract multiples of one full rotation. Okay, so 360 times n, okay, where n is some number of integer rotations. And since 360 is equivalent to what in terms of radians? 2 pi n. So this is in degrees, and this is in radians. Okay, so if I asked you to find coterminal angles, one positive and one negative, and I gave you 7 pi over 12. Okay, what would be a positive coterminal angle with that? Okay, we add 2 pi. Okay, 2 pi is how many twelfths? What can you divide by 12 to get 2? No. Don't divide 12 by that number, but what number can you divide by 12 and get a 2? 24, right? 24 over 12 is 2 pi. So when we add this, our denominator can stay the same, and we get 24 plus 7, which is 31 pi over 12. So there would be our positive coterminal angle. Olivia?
I don't understand how you come up with 3 pi over 12.
Because here's the way to find coterminal angles in a radian measure is to add some multiple of 2 pi. So we're just going to add 2 pi. 2 pi is, since we're in twelfths to begin with, when we add the value, we want it to be in twelfths as well. So 2 pi in terms of twelfths is 24 twelfths.
Oh, so 12 is n?
Well, no, n is just 1. Right, so the n right here just means more rotation. So basically, if they ask you to find 2 positive coterminal angles, 31 pi over 12 would be 1. And then the next one, we would add another 2 pi to that. That's what the n just means, multiples of 2 pi. So if we added another 24 pi over 12, we would get 55 pi over 12. That would be another possibility.
Why wouldn't you multiply 7 pi by 2 pi?
Well, you don't want to multiply it. All you're doing, because if we found this coterminal angle with 100 here, we didn't take multiples of 100, right? We just took 100 and added it to multiples of 360. So we got 460. If we added another 360, we'd get 820. If we added another 360, you could find all the different positive coterminal angles.
So you always use the denominator to find what you're adding by?
Yes. In terms of the radians, yes. Saber, did you have a question?
Well, what if that number wasn't 2 pi? Let's say it was 3 pi.
No, this is always going to be some multiple of 2 pi. because that's a full rotation around the circle. In order to find coterminal angles, again, those are angles that have the same initial side here and the same terminal side. So again, if we found all the different angles that have the same initial and terminal side, the original angle is 100. If we went from this original angle where it ended and we rotate all the way back one more time, back to itself, how many degrees is that rotation? 360, right? Just from here, from this terminal side all the way back to itself. And then what if we did it another time? Now that's 2 times 360. So that's what this multiplier n means. And if we did it a third time, 3 times 360. So that's where this n is just a number of full rotations. Around whatever that circle is. Okay, so if we wanted to find a negative coterminal angle, Olivia.
How do you find the 55 pi over 12?
How do you find the 55 pi?
Yeah.
If this would be the next coterminal angle if we continue to rotate. So like 7 pi over 12. So if you were looking at this in graphic form, okay, is 7 pi over 12 going to be past 90 degrees?
No.
Okay, now remember, as far as the pi's go, 0 is 0, 90 degrees is pi over 2, and then 180 degrees is pi. So we know it's between 0 and pi, right? Well, is this greater than 1/2, 7 over 12? Yeah, so we know it's going to be just a little bit beyond that, right? So it's going to be somewhere around here. So this right here is 7 pi over 12. And so if we took this angle, we rotated all the way through, which was 2 pi, plus another 7 pi over 12. That's what we got right here in this calculation, because 24 over 12 is 2. And so if we wanted to find what the next one would be, so if we rotated this one more full rotation, so we would take 31 pi over 12 and add another 24 pi over 12 to that, and that brings us to that next rotation. And then you could keep adding 24 pi over 12 if you wanted to find more positives. To find the negative, what would we have to do? We take 7 pi over 12 and do what with it? In the negative direction, we're going to take the difference. So subtract 2 pi, which is 24 over 12. Again, the only reason I'm thinking of it in terms of 24 over 12 is so you can combine these mentally. You don't have to use a calculator. So if we took this, we see that the difference, we know it's going to be negative. The difference is 17 pi over 12. And so that would be your negative coterminal angle. And if we found another one after that, we'd just subtract the 24 over 12 from this. So then we'd get a negative 41 pi over 12. So you could keep going, again, rotating it unlimited number of multiples of 2 pi. And now, you guys do get to use your calculators, right? So if you're going to do this with your calculator, okay, if you took 7 pi divided by 12, as long as you're in auto mode, it's going to leave it in that form, right? It's not going to convert it to decimals or anything for you. And so if you took this and you added 2 pi, you'd get 31 pi over 12, which is what we got here. If you add another 2 pi, you would get 55 pi over 12, which is what we got here. If you had taken your 7 pi over 2, and now we subtract 2 pi, we get our negative 17 pi over 12. If we subtract another 2 pi, again, all we're doing is we're confirming what we did mentally with the calculators.
So 2 pi is just equal to 1.
One full rotation there. And again, the easiest way to remember that, the whole 2 pi radians is one full rotation. And that's simply to take the circumference. The circumference of a circle is 2 pi r. And what we're going to talk about here in just a moment is a unit circle with a radius. A unit circle has a radius of 1. So the whole rotation along this full rotation here, when the radius and the arc are equal to each other, is just 2 pi. Saber?
Is 2 pi always going to be a rotation? Like, is it
Yeah.
for every equation?
Yes, it'll.
Add
2 pi in terms of radian measures, yes, 2 pi is 1 full rotation around a circle. 2 pi, like 360 degrees of a circle is equivalent to 2 pi radians, always.
So you only need to like multiply the denominator by 2 times pi over 12 if you're not using calculator.
If you're, right, yeah, if you're using calculator, just use 2 pi. All right.